Seventh graders, we're going to start chapter 10. Chapter 10 is about area and volume. It's a kind of a preview to geometry, and it's going to help review with you some of the major concepts of geometry. For example, area, volume, and perimeter. Okay? We're going to talk about area today. And we're going to start with what we know about rectangles, okay? Rectangles have a base and a height, don't they? Okay? And in the formula for a rectangle, we use the base times the height to find the area. Now, area, what I want you to think of is like, if we were to carpet this room, we'd have to order the area of the room in order to get the right amount of carpet. Area is always labeled in square units. So if this room is 15 by 20, then we'd multiply 15 times 20, which is 15 times 2 is 30. 15 times 20 is 300. And we would order it in square units. Square feet, right? So, area is labeled in square units. Today we're going to be talking about parallelograms. Yep, parallelograms. Now, a rectangle is a parallelogram because a parallelogram is any figure where the opposite sides are parallel. Okay? Look, in a rectangle, this side, the top and the bottom are parallel, and the two sides are parallel. So that's a parallelogram. Right? This is also a parallelogram. The top and the bottom are parallel, and the sides are parallel, but they're not perpendicular to the other side. Are they? It's still a parallelogram, but it's this rectangle and it's slanted, isn't it? However, we still use the same formula to find its area. We use the base by the height. However, the height cannot be the slanted side. The height has to be an imaginary line that is perpendicular to the base. Right? The height has to go straight up and down. It has to be perpendicular to the base. So what we're looking for when we find the area of a parallelogram is a line, either imaginary, like this one, or the actual side, which forms a 90-degree angle to the base. And this is the line that we use for the height. It's called the altitude of the figure. The altitude is always perpendicular to the base. Repeat that. The altitude is always perpendicular to the base. Okay? And then the area for a parallelogram is base times height. Repeat. Right. Altitude, line perpendicular to the base, it's also called the height. So, look at this example. Yep. Here we have 3 dimensions, don't we? The side is 12 centimeters. This is 13 centimeters. And this line is 10 centimeters. What would we use to find the area? What would we use to find the area? Which numbers? Look for the numbers that are perpendicular. The sides that are perpendicular. Is this one perpendicular to anything? Does it form a 90-degree angle to anything? No. It doesn't. This one forms a 90-degree angle with this one, doesn't it? So those are the two lines that we use to calculate the area. Okay? The area is 130 centimeters squared. Right? So put this one in your notes. In your notes, yep. Now, in parallelograms, one of the things that you're going to be doing today is graphing the parallelogram. Okay? What you're going to do is use the points that are given to graph the parallelogram, to mark the points and connect the lines. So let's look at the first one. Oh, I need grid paper. Grid paper? Yeah, graph paper on here. Yeah.
Grid?
Yep, grid or graph.
It says grid right there. Is that what you want?
Yeah.
Chris, I'll go through that.
Visible.
Grab the points.
Aha, thank you. Now, so let's say that this is our 0 line. Okay, and let's do number 1 together. They give us these points. -1, 2. So graph -1, 2. 3, 2. 1, 1. And -3, 1.
Yeah, which one is wrong? Yeah, we did -1, -2.
Oh, I'm sorry, I did -1, -2. That's why I didn't look very much like a parallelogram. -1, 2. There we go. Now, we should connect these so that it forms a parallelogram. So these two lines have to be parallel, and these two lines have to be parallel. Right? Each one of these corners is called a vertex. Or actually, they're all called vertices. The single one is called a vertex because it forms an angle. All right? More than one vertex is called a vertex. Then it says find the area. So what is the base of this figure? We count the number of spaces. 1, 2, 3, 4 spaces, right? From here to here is 4 spaces. Right? And what is the height? The height is perpendicular to the base. So from here to here is 1. So how do we find the area? 4 times 1.
4.
4. And how do we label it?
Centimeters.
Not centimeters. These are they're just regular units. In this case, it doesn't say 4 feet, 4 centimeters, 4 inches,
4 units.
4 anything. It's just 4 units squared. 4 units squared. Okay? Number 2. Let's do number 2. -2, 1. 2, 1. Wait, let's do this. here we have our coordinate plane. Negative 2, 1, 2, 1, negative 3, negative 2, and 1, negative 2.
Wait, are you on 3 or 2?
I'm on number 2. Negative 2, 1.
That doesn't,
2,
that's
1.
not right. That's not what I got.
Oh,
That's not
negative 3. Sorry.
The confusion begins.
Negative 3. Stop talking and figure yours out.
It's negative 2, 1,
3,
not negative 2.
negative 2.
It's negative 2, 1, not negative 2, negative 1.
Negative 2, 1. There we go. Now find the base. That's the number of spaces. 1, 2, 4 again, right? 4 units. And the height? 3 units. Yep. So the area is
12 units squared.
12 units squared. Right? That's it. That's what I want you to do for tomorrow. Is just finish lesson 10-1, do 3 and 4, and then also get your notes ready to grade tomorrow. Okay?